everybody. Good morning. Today is Monday, October 23rd. Have you been working on your practice exam? So the practice exam is due tomorrow. And then your exam is on Wednesday. So come here earlier on Wednesday. And if you need more time, you can stay after class. I will be teaching Cal 2 in this room. So yeah, you just finish your exam and then put it on my desk and then leave, right? If you need more time. Okay, so today we will continue on session 5.3. So today my office hours is from 1 to 1:50 and after 3:07. So after 3:07, I will be in the classroom Snyder 246. Okay, so that is my pre-calculus class. I asked them to stay and do the practice exam. So I will be in that classroom 246. So it's a classroom. So more students can come. So if you have questions, okay, feel free to come to see me this afternoon. But it's gonna be in the room 246. Okay. And tomorrow I also have office hours from 11 to 12. Okay. And if you cannot come to my office hours, feel free to email me. Let's say tomorrow evening you have questions you want to ask me before you take the exam. You can email me, and then maybe we can all go to TED Live, and then the virtual classroom. You can share your camera, share your screen, and ask me the questions. Okay, everybody? So do the practice exam. Oh, by the way, may I ask you your permission to post the lecture videos? So I've been taking the recordings of all the videos. I want to post it on the website. So my next Applied Cal 1 class, if sometimes I forget to click start recording, they can look at our class recording. May I have your permission? All of you? Yes, thank you. Okay. Because in the recording, they might hear your answers. Okay, let's continue. All right. So let's see. Last time we talked about second derivative. Do you remember? The first derivative tells us whether the function is increasing or decreasing, right? And then the second derivative tells us whether a function is counting up like a bowl, right? Or counting down like an umbrella, right? Okay. And then we also talk about the inflection point, right? Inflection point compared with the critical point. Critical point is about the first derivative. The inflection point is about the second derivative. Yeah? Critical point has three things, right? First is in the domain, and second is either the derivative is 0 or third, the derivative does not exist. Three things, right? The inflection point, okay, is in the domain. The second derivative is either 0 or does not exist. We need one more thing. We need to make sure the second derivative change sign. Right, everybody? Because inflection point is like a turning point, right? Imagine you're driving, a turning point, you must change your direction. So you're turning left, and then you turn right, you must change direction. That's why your second derivative must change sign. Is that okay, everybody? And then last time we did example 1, right? We find the interval. Oh, we haven't finished. Okay, so let's continue. All right, so we have this function, and we want to find the interval of concavity and the inflection point. So we first take the derivative, and then we take one more derivative to get a second derivative. Our goal is to factor, right? So if you see all the terms have positive exponents, your goal is to factor, and then you set it equal to 0. But if you see some term has negative exponent, it means that x power is actually in the denominator. fractions into a single fraction, then you want to factor the numerator and denominator. The numerator equal to 0 corresponds to the second derivative is 0. The denominator equal to 0 corresponds to the second derivative does not exist. So the process is similar. It's just instead of the first derivative, you look at the second derivative. Oh, it's tangents. Okay, so we have a new sheet today. Yes, it's already the 10th week. Ooh. Okay, so after we factor this, we set each factor equal to 0. Okay, Blaine, what is x? Yes, negative 1/3. Or? What did you say? X minus 1 is 0? Yeah, x is 1. Yes. So we have 2 points here. Okay? And then we also need to find the domain. Remember, for domain, we look at 3 things, right? What's the first thing? Does it have square roots? Does it have square roots? No. The second thing, what's that? Fraction. Does it have fraction? No, right? The third thing, what's the third thing? ln. Do you see ln? No. Okay, so the domain is everywhere. Okay, minus infinity to infinity. So when we find the critical points, okay, critical point, look at the first derivative and find the then your denominator cannot be 0. The domain is not always numbers. But x equals -1/3. No. We mean x in the denominator. Oh. Yeah, x squared minus 1. Oh. Like this. Then in the denominator, or the exponent is negative. Okay. Yeah. But in this case, it's still in the numerator, so no problem. Right. Okay. Yes. So when we find the critical points, like at this stage, we can say they are critical points. So when we say inflection points, at this stage you cannot say they are inflection points because you have to make sure the second derivative change sign. That's why you go to step 2. Okay, the real number line minus infinity to infinity separated by those numbers, okay? So negative 1/3 and 1. So we get negative infinity and negative 1/3. Negative 1/3 and negative 1. Oh, sorry, it's positive 1. Positive 1 and infinity. Okay, because here we're talking about intervals of concavities, so we care about the second derivative and the f. Is that okay, everybody? The second derivative, we want to know whether it's positive or negative or 0 or does not exist. And then the function we care about is concave up or concave down, or whether they are inflection points. Okay, this is what you want to fill in. Now let's see. At x equals negative 1/3 and 1. Do you see the second derivative is 0? Because this is how you find those two numbers. You set this equal to 0. Therefore, the second derivative is 0. Okay, now let's pick some test points. Will, what test point do you take on the left? Yes. Negative 1. Do you plug in the original form or the factor form? Factor form. Okay, so 12 is positive, right? Yeah. And you plug in negative 1. What's the second factor? Negative. The third factor? Negative times negative is? Positive. Good. Yes, this is positive. Okay, Dylan, how about the middle interval? Yeah, we're talking 0. 12 is positive, and then the second factor is positive. The third factor is, so the answer is negative. Yes. Paige, what number do you pick? From 1 to infinity? 2. And 12 is positive, and when you plug in 2, the second factor is positive. The third factor is positive. So the answer is positive. Very good. So far, so good, everybody? Okay, Dante. If the second derivative is positive, then your function is concave up or down? Up, yes. So like a ball, concave up. If your second derivative is negative, then your function is concave down, right? And this is up again. See? This point, the second derivative changed sign from minus to plus. So this is in fact inflection point. Right, everybody? So we put inflection point. Also, the next one, the second derivative changed from minus to plus. This is also an inflection point. So we have 2 inflection points here. Right, everybody? So we can say F is concave up on the interval minus infinity to negative 1/3 and also 1 to infinity. F is concave down on the negative 1/3 to 1. And F has inflection points, they're like turning points, x equals negative 1/3 and x equals 1. So far, so good, everybody? Okay. Very good. Okay. So this is example 1. Okay. Let's keep going. The next example, I want to save some time. So let's look at the notes with answers. Okay. So we finished the first example. A second is we want to talk about the theorem, the second derivative test. Do you remember what is the first derivative test? The first derivative test, what do you mean? This is the first derivative. The first derivative test tells us if your first derivative is positive, then your function is increasing, right? And then your first derivative is negative, then your function is decreasing. So if your function increases and decreases, then this is a local max, right? And then if your first derivative is negative, then your function is decreasing, right? And then your first derivative is positive, your function is increasing. So decrease and increase, what do you say? Local mean. So that is the first derivative test. You can use the first derivative to figure out that critical point is a local max or local mean. Okay, everybody? So here we have a second derivative test. The second derivative can also tell us whether a critical point is a local max or a local mean. Okay, let's see. Suppose the second derivative on an open interval, second derivative continues on an open interval containing c with f prime of c equal to 0. If the second derivative is positive, then your function concaves up, right, everybody? Concave up. Do you see down there? Concave up, then this is a local mean. Okay, everybody? And then if your second derivative is negative, then the function is concave down. Right, everybody? Concave down. Then this is the local max. Right? Concave down. It looks like a mountain. That is local max. So I have a typo on your worksheet. Please fix your worksheet. Okay? So you can draw the picture, then you can figure out is local mean or local max. But if the second derivative is 0, then the test is inconclusive. So which means we cannot use the second derivative test. Please use the first derivative test. That's why I put a clause there. So in the exam, you only need to use the first derivative test to tell whether the critical point is a local mass or local mean. You don't need to do the second derivative test because you need to take the second derivative. If the derivative of the first derivative, it requires more work, right? And sometimes it could be inconclusive, which means this test does not work. You need to do the first derivative test. That's why I put a clause there. I just want to introduce this theorem, but I don't recommend you to use this theorem. Okay, just use the first derivative test. Is that okay, everybody? So that's why example 2, I want to show you quickly. Do you remember this problem? We actually did this problem before, okay, in the last class. Okay, remember you take the first derivative and then you have 4 terms. You group the first 2 together and you group the last 2 together. Do you remember this example? Yes. So from your previous worksheets. And then you can factor out the x minus 1. You get 12 times x minus 1, and then you have x squared minus 1 is the difference of square. So you can factor them. That's why you get 12 times x minus 1 squared and times x plus 1. And then at the time, you get the critical point was 1 and negative 1. Do you remember that, everybody? And yeah, last worksheets, we also use the first derivative test. You draw the table and then you find the first derivative, whether it's positive or negative, then you can tell whether the function is increasing or decreasing. Is that okay, everybody? Do you remember that example? Maybe I can show it to you. So that is 5.2. Where's 5.2? Here. And we go down, which is, yes, this example. Do you remember this example? We did this before. And we use the first derivative test. We can see we have a local mean at negative 1. And at 1, it's neither local mean nor local max. Do you remember that? Okay, now we figured out those 2 critical points. And if we want to use the second derivative test, we need to take the second derivative. And then, see, when you plug in 1, the second derivative is 0, which means no conclusion. Okay? And when you plug in negative 1, oh, the second derivative is positive, so the function is counting up. Right? Counting up, this is the local mean. See? The second derivative test only tells us that negative 1, x equals to negative 1, is a local mean. But it cannot give us any conclusion about what happens when x equals 1. Okay, everybody? That's why the first derivative test is more powerful. You can always get the conclusion. You know what happened to the critical points. Okay, so so the second derivative test, I just want to let you know, but I don't recommend you to use it. Okay, everybody? Yes. Okay, so this is example 2. Now let's look at example 3. Okay, so you want to discuss the curve with respect to concavity, points of inflection, and local max, local mean. Use this information to sketch the curve. Okay, so sketch the curve, which means you need to find the first derivative critical points, and also you need to find the second derivative and find the points of inflection. So, okay, we have more steps. Step 1, find the first derivative. Okay, who's next? Josh. What's the first derivative? Yes. Okay, and our goal is to factor it, right? Let's see, Gabby, how can you factor it? 4x squared out, and what's left? Yeah, very good. So we factor it completely. Then we set this factor equal to 0. So far, so good, everybody? We set each factor equal to 0. You see? X is 0 or x minus 3 is 0. It means x is what? Yes. So we have 2 critical points. By the way, because this is a polynomial, you know, for a polynomial, domain is negative infinity to positive infinity. Right, everybody? Okay, so now we know both of them are critical points. They are critical points. Okay, second step. We want to take the second derivative. Question! Should we take the second derivative? Do we look at the original form or do we look at the factor form? Original form, yes. Because we can use the power rule. If you look at the factor form, oh my god, you need to use the power rule. Right, everybody? Yeah, so we need to look at the original form. So what is the derivative of this? Mackenzie? Yes, thank you. And how can you factor this, Leila? Yes, very good. So we set it equal to 0. What are the roots? 0 and what's x? 2. Right, everybody? But at this step, can we say they are inflection points? No, because we have to make sure the second derivative change sign. Right, everybody? So they're just possible inflection points, but we cannot guarantee they're inflection points at this step. Okay, that's why the third step is, now please make a longer line. Because this longer line, you want to separate it by the critical points and the possible inflection points. Okay, they have 3 numbers, 0, 3, and 2. Which one is the smallest? 0. And then the next number is 2. And then the next number is 3. Okay, everybody? So the left interval is minus infinity to 0. And then 0 to 2. 2 to 3. 3 to infinity. Right, everybody? Okay, let's see. All right. So if we care about like intervals increasing and decreasing, then our table, we need to have f prime and f. If we care about concave up or down, our table should have f prime prime and f, right? Now, because we care about everything, so the table should include f prime, f prime prime, and f. Is that okay, everybody? So for f prime and f prime prime, you also want to talk about is it plus or minus or 0 or does not exist. Okay, So you're feeling the same thing. But for the F, okay, what do you want to fill in is, okay, so you have a circle. You cut it into 4 pieces. Can you imagine a circle and then you cut it into 4 pieces? Okay, let's see. Oops, sorry. Okay, do you see this piece is increasing and concave down? Yes, everybody. This piece is increasing and concave down. And how about this piece? Yeah, very good. How about this piece? This piece? Decreasing and concave up. Yes. How about the last piece? Increasing and concave up. Exactly. So for the F, you want to fill with this one of the 4 pieces. Is that okay, everybody? Mm-hmm. Be careful. Don't fill in the parentheses. Don't fill in the parentheses because if you put a parentheses, it's hard to tell whether it's increasing or decreasing. Okay, so it must be one of those 4 shapes. Okay. All right. Now let's see. Okay. And let's look at the first derivative. So the first derivative, we have 0 and 3, right, everybody? 0 and 3. The f prime is what? 0 and 3, f prime is 0, right, everybody? Mm-hmm. Okay, do you see 0 and 3 actually it separates the real number line into 3 sub-intervals? So actually this guy will be same sign. Is that okay, everybody? Mm-hmm. So on the left interval, what number do you pick? From minus infinity to 0. -1. Yes. Okay, Blaine. If we plug in -1, do we plug in the original form or the factor form? Yes. We look at the factor form. Okay, if we plug in -1, what's -1 squared? 1, so positive. -1 minus 3 is positive or negative? Negative. So the answer is negative. Yes. Right, everybody? Mm-hmm. And then the middle, Will, what number do you pick? Mm-hmm. Do you see the middle from 0 to 3? This 3 region, it will be the same sign. Okay? So we can pick 2. Yes. 2 squares. 4. So positive. 2 minus 3 is -1. So your answer is negative. Oh, if this is negative, then those 2 regions will also be negative. Okay, so you don't need to pick 1 in the region like 0 to 2, 2.5 in the region of 2 to 3. You don't need to pick those because you know they will have the same sign. Is that okay, everybody? Mm-hmm. How about from 3 to infinity? What number do you pick? 4. 4 squared. Positive. 4 minus 3. Positive. So the answer is positive. Very good. Yes, everybody? Mm-hmm. Okay. Let's see. Next number. Second derivative. Where do you put the 0 at? Page. What are the roots of the second derivative? 0 and 2. So they are the roots. Right, everybody? Do you see it separates the real number line into what? 3 regions. So in this large region, it will be same sign. Okay, everybody? Mm-hmm. Okay, so this is how we think. Okay, the left interval, what number do we use? We use -1. So we plug in -1. The 12x is positive or negative? 12x. If we plug in -1? Negative. And x minus 2. Negative. Negative times negative is positive. So this is positive. Right, everybody? See, if you plug in the factor form, do you need a calculator? No, right. Okay. How about next one? What number do you pay? Down J. 1. If you plug in 1, 12x is positive. X, huh? Positive, negative. So your answer is negative. Very good. Josh, do you see that 3 regions? This one, and this one is the same sign? Oh, okay. So what number do you take? You pick a 4, and you got all positive. Yeah, very good. So we got positive, positive, and positive. So far, so good, everybody? Yes. So look at where you get 0 or it does not exist first. It's separate the root into 3 spots. Okay? And then, so you know this 3 region will have the same sign. You just need to find one number to plug in, and if you get positive, they're all positive. Okay. Yes. That will save you some time. Now let's see. Okay. Look at the first one. Let me go to here. Okay, Gabby. So f prime is negative. The function is increasing or decreasing? Decreasing. Second derivative is positive. The function is concave up. Decreasing and concave up. Which one? Left, right, up, down. Bottom left. Yes, decreasing and concave up. Bottom left. Can you see that, everybody? Bottom left. So put the shape there. This is the actual shape of the graph. Okay? This is actually the actual. Okay. Actual shape of the graph. Okay. Next one. Mackenzie. So your f prime is negative, then your function is increasing or decreasing? Decreasing and concave down. Which one? Left, right, up, down. Top, right. Yes. See? It's this. So far, so good, everybody? Okay, and then Layla. Your f prime is negative, so decreasing and concave up. Which one? Left, right, top, down. Bottom left. Yes. Right, everybody? Yes. Okay, how about the last one? How about the last one? Increasing and concave up, so it's bottom right. Exactly. Yes, very good. Okay, everybody? So you see our graph go down and then like this. Or do you say this thing? This is is it a local max or min? No, but it's an inflection point, right, everybody? It changed. Yeah, so this is an inflection point. How about this one? it goes down and then this. What do you say this thing? It's also inflection point, right? Yes. And then it is like this. What do you say? Local minimum. Sorry, I draw too big. There are more steps because our goal is to sketch the graph. Okay, so we haven't sketched the graph yet. Let me shrink this. Do you still have enough space? Okay, good. Let me shrink this. This is a good thing about Word. I can shrink it, and I can copy and paste. Okay. Okay, so now step 4 is to plot the important points. Okay, we have 3 important points here. Okay, so step 4. Okay, we plot the important points. So we need the 0 and the 2 and the 3. Okay, if we plug in 0, what happens? Bang! Yes, to the original function. What do you get? Yeah, just 0. Right, everybody? Woo! We plug in 2, what happened? Let's write it down. What's 2 to the 4th? And 4 times 2 cube? Yeah, 4 times 8 is 32. 16 minus 32 is negative 16. Yes, very good. Dylan, if we plug in 3, what happened? What's 3 to the 4th? So 3 squared is 9. 9 times 3, 27 times 3. Yeah, 81. 81 minus 4 times 27, right? Oh, actually, what's 4 times 27? 108. So 81 minus 108 is negative 27. Yes. So find the important points and let's plot those on the graph. Okay. Step 5. Grab it. Okay. The important point are, okay. I see that X is here, Y is here. Do you see 0, 0? And then 2, negative 16. Let's say this is negative 16. And then 3, negative 27. So when you draw the graph, the scale not need to be very accurate. Okay, so don't put 27 far. Just put one number and say, oh, that's negative 16. Just put another bar and say that is negative 27. Okay, everybody? So don't put so many bars there. Yes, make your graph clean. Okay, now, see? At each piece, move the shape. See? 0, 0 is here, right? And then your actual shape on the left is what? Like this. So you copy and paste here. Can you imagine, everybody? So the actual shape, copy and paste. So we have something like this. Right, everybody? And then next one is what? This. Yes. Copy and paste. So connect those 2 points, copy and paste. So draw it better like this. Yes. And then next one is what? Connect the points and copy the actual shape. Is that okay, everybody? And then the last one is what? Oh, go up. Yes. go up. So this is the graph. This is what the graph looks like. Do you see it's very smooth? Polynomial should be smooth. Okay, everybody? Yes. If you have a rational function, then you expect to see vertical axes. And sometimes you might have horizontal axes. Right, everybody? Okay. So this is example 3. Now, everybody, please do example 4. Okay, it's your turn now. So follow those 5 steps and do example 4. So Wednesday, come here as soon as possible. I will be here after my phone. Oh, don't do it all together. If you do it separately, it's hard to break it. Because like, if you do it all together, you can break it and see the actual shape of it. Like where is it? Like the previous problem. You do it all in one table, and then you can see the actual shape of it. So you have a giant table like this. It has the first derivative and the second derivative and the app. Okay? And and your F, you draw the action shape. It's just like the circle where you cut it into four pieces. Okay, so let's continue this example on Friday. So Wednesday is the exam, okay? So study hard on the practice exam. Remember you first use pencil and then you use red pen to grade your work, estimate your scores, and write down the correction. Okay? So feel free to come to see me. Today I have office hours from 1 to 1:50 in my office. And then in the afternoon, like after 3:07, I'll be in the classroom 2:46. Okay. Bye. Hmm? Huh? Oh, after like 3:07. Mm-hmm.